let me get this straight. You swallow some protein, it goes from your stomach straight to your biceps and boom, gains. I mean, what the heck's going on here? Fear not. Today we're breaking down how protein actually works inside your body. But before we go deeper, let's clear what protein really means. Every protein is made of tiny building blocks called amino acids. They're shown in different colors because not all amino acids are the same. These amino acids link together like beads on a thread. A few beads make a peptide, and when you've got hundreds or thousands tangled up together, boom, that's a protein. A quick question that always pops up: can protein target specific areas, like just your arms, chest, or hair? We'll talk about that later on. Okay, let's jump to the process. Digestion starts in the mouth. Chewing breaks protein-rich foods into smaller pieces, and saliva makes them easier to swallow. If it's a protein shake. In the stomach, protein digestion truly begins. The stomach releases a strong acid called hydrochloric acid and an enzyme called pepsin. Together, they start breaking large protein molecules into smaller fragments called peptides. Yup, that bracelet chain. This acid also helps kill harmful microbes and detangles protein structures. The stomach keeps squishing and mixing everything with its juices until it turns into a thick soup. From the stomach, the food soup moves into the small intestine, where digestion keeps rolling and absorption finally begins. The food coming in is still super acidic, so bile and pancreatic juices step in to cool things down. Next, the pancreas releases its enzyme squad straight into the intestine, slicing big protein chunks into smaller peptides and setting the stage for the main player, the little gangster. Inside the small intestine, the inner wall is covered with tiny finger-like villi, and each one is topped with even smaller microvilli, all lined with special cells called enterocytes, or as I like to call them, lil gangsta. Each lil gangsta's got its own crew of enzyme goons ready to pull up and finish the job, turning the last peptide bits into pure amino acids and immediately absorbing them. Some leftover peptides sneak inside our lil gangsta for one last round of digestion, the final choppy before it's done. Okay, no more choppy now. As a reward for all that work, our lil gangsta keeps a few amino acids for itself and sends the rest into the tiny blood vessels inside the villi, heading straight for the next stop, the liver. After digestion and absorption, amino acids officially enter the bloodstream, but they don't go straight to your muscles. First, they report to the liver, the body's main control center for nutrients. Here, the liver decides what your body needs most. It keeps about 50% amino acids for themselves to make plasma proteins, enzymes, and hormones, or converts some into energy or glucose. The rest, especially the BCAAs, are released into the blood for muscles and other tissues. Once the amino acids are in circulation, they travel through your blood to reach different tissues. When you work out, your muscle fibers get tiny micro-tears. Amino acids rush in to repair and rebuild those fibers, making them stronger and thicker over time. That repair process is what we call muscle growth. So where the rest goes? Not all amino acids end up in muscle, and that's completely normal. Some are used to build enzymes, hormones, skin, hair, and immune cells. If your body still has extras, it removes the nitrogen and converts what's left into glucose for energy, or stores it as fat if you overconsume. And that question, can protein target specific areas? Nope. Protein doesn't have Google Maps. Once it's broken down, your body sends it wherever repair's needed. Alright gang, that's it. Don't skip your protein, and don't skip that subscribe either. I'll see you in the next one.